Welcome to the second lesson on structured cabling. This is a multi-part lecture series that I will be posting on my YouTube channel. If you haven't seen my first lesson, I will leave a link in the description for the playlist. Today, our primary focus is going to be the key structured cabling standards in information technology. Remember from my previous lecture that I introduced you to standards, and I defined the standards as the specifications that guarantee a minimum level of performance and are used to quantify and qualify materials and components. So the standards were brought forward or introduced because that there are multiple vendors, manufacturers, equipment suppliers, installers. They all need to be on a single page when they were actually working on different structured cabling environments. So without standards, many different companies would come up with many different way of dealing with this issue, and then we will end up with multiple different cabling standards. So that's why we have standards. So remember from our previous lecture, the standards are specifications that guaranteed a minimum level of performance that are used to quantify and qualify materials and components. Remember also from the previous lecture that the importance of American AT&T and Bell Laboratories and how they play a vital role in modern standard, not only in the United States, but also in the global markets. Because AT&T and Bell Laboratories were so big, they play a vital role in the infrastructure of what we modern day call information technology structured cabling standards. Also recall that two major standard organizations that include ISO and TIA, but also ANSI, which is the American Institute for Standards. They are all major players, but ISO and TIA is the major two that you should remember. Moving on from that, I'm going to discuss something called de facto standard. So standards are not always based on a new technical definitions created by ISO and TIA and ANSI, etc., but rather based on current industrial practices, local regulations, etc. So while there are standards that directly introduced by the standardization organizations such as ISO and TIA, but there are a lot of other standards that came about because of a de facto use of it. If a standard is based on pre-existing practice, it is known as the de facto standard, and the standard organization will take that standard sometime, those pre-existing practices, and make it more universally accepted with consistent information, make sure the technical standards are more complete, and encourage flexibility for future development and support for legacy devices, and allow interoperability between different standards, and also allow the ability to level the field for all manufacturers, installers, engineers, and companies, etc., etc. So what a de facto standard is, if you get that question on an exam, or for somebody ask you what is a de facto standard. De facto standard is basically there has been a long practice, like a long-term practice of putting cables in a certain way, or arranging cables in a certain way using certain types of cable in the industry. And because of this long-term widespread use of that particular methodology, that become the de facto standard. So in other words, there are no centralized bodies such as ISO or TIA standardizing bodies telling the industry what to do, but because of the industry is facing certain economic and other economic and other pressures in the capitalist open market environment, they will come up with solutions, and those solutions become sometimes de facto standards. An example would be the early stages of the telecommunication industry, even early stages of information technology industries. Many companies decided to use a specific methodologies of installing cables. And when the ISO and TIA came about, they actually used those de facto standards, those widespread standard, and make it more universally accepted and make those technical standards more complete. So keep that in mind as we move through this class. The other term that you should be familiar with is called de jure standards. What de jure standard means, as manufacturers and other organizations compete in the competitive industry, they have came up with many different standards, and if the quality of these standards and variations of it become very, very popular, that means quantity increase, the use of it increase, that will lead to something called de facto standard to become de jure standards. So what that means, there is not really standard organization that pushing these standards. Because of that, de facto standards become de jure standards as the industry move forward with one particular way of installing structured cabling. New standards must consider the backward compatibility, support for grandfather systems, and those two key points are very important when people, organizations are introducing new standards. So backward compatibility means basically new standards in most part has to be backward compatible in order to be widely accepted and implemented. For example, if a Cat6 cable cannot handle Cat5e type of transmission, that's not good, right? Because the less likely people are going to adapt that. That's not the case, by the way. You can transmit lower frequencies even on and lower bandwidth on even on Cat6 cable. For example, you can install a Cat6 cable and just use 10 megabyte or less, on the cable. That's no problem. So that means it is backward compatible. Industry and large-scale infrastructure cannot be updated or upgraded on a short period of time. So that means backward compatibility allow the step-by-step upgrade of network infrastructure. So you could have parts of your cabling infrastructure on Cat5 cables, part of your infrastructure being renewed onto Cat6 standards, and that's perfectly fine because it can interoperate between those standards. For example, Microsoft still support all DOS-based programs even on Windows Server 2022. Like you can install Windows Server 2022 and run a DOS script on that. Modern days Microsoft Server scripts are based on Windows PowerShell, but you don't need the PowerShell if you have an older script that you specifically need to access, let's say an IBM mainframe, for example. So even Microsoft brand new products, when it's come to the point software side of things, they still support the backward compatibility. In terms of grandfather system, there are situations where older system must still be supported, especially in large organizations such as banks, large corporations and governments, and IBM mainframe again come into mind, where they still use things like COBOL, I think 30-40-year-old programming language being used to support those older systems because they are still reliable and still do the job at a lower cost. Both of the key points that I described here, their backward compatibility and support for grandfather system, has to take into account cost benefit analysis. So no company in Canada or United States or even in socialist countries or communist countries even or socialist countries where government funded programs are more prevalent than more open market economies, even in that situation people do consider cost benefit analysis, because why would you want to waste your money on a new system if that system is not bringing in the benefits that you need. So for example, there's absolutely no reason right now for most Canadian households in 2022 to wire their entire internal local area network inside the house with fiber optic cables, because there are no internet service provider in Canada that fully utilize the fiber optic end-to-end speeds. So therefore, why even as a consumer would you want to spend hundreds of thousands of dollars wiring a house internally with fiber optic cable? Instead, you maybe use Cat6 cable. Even Cat6 cables are not needed because Cat5e would do the job as well. So that means not only we need to think about backward compatibility and support for grandfather system with the new standards and new cabling standards, but you also need to look at the cost benefit analysis. So like I said, there is no need for many small businesses, even large businesses, to use fiber optics inside the building. But you need to look into cost benefit analysis. If there is a need for it, then you can use it as such. So whatever the standard you come up with, backward compatibility and support for grandfather system are key things that will define whether the standard going to be successful in the open market. Important standards for IT professionals. Few key items that is probably you are already familiar with, but you may have heard those terms, but you would probably not be familiar with where they are coming from. Especially if you are a student, this course is specifically designed for someone who is new to information technology industry or students. So when you plug in an Ethernet cable, what do you actually plug in? Right? You have a cable and you plug it in, and you can buy any switch from any company such as Cisco, D-Link, and you can buy any pre-made Cat6 or Cat5 cable and you can plug it into that switch. So when you plug an Ethernet cable, what do you think? What are you plugging in? Probably not. But if you're an IT professional, you would and you should actually think about that. So what makes that end connection work? What makes that end connector work? Well, the wiring sequence is actually arbitrary. So we have two wiring sequences, one called T568A and T568B for wired cabling Ethernet connections for RJ45 pinouts. And the sequence in which how we wire these items, like how we wire these each cable, each of these wires in this cable is actually arbitrary. So human made the Ethernet and human came up with this. But as opposed to, let's say, if you're studying biology, how the heart function or how the brain function, how cells have osmosis process, for example, has nothing to do with arbitrary, regulations or, arbitrary decisions made by humans. It's actually we are studying nature, and it's a study, the way how brain function is how the nature function, right? But when it's come to information technology, network engineering, computer systems, a lot of the things that we use are arbitrary. Keep that in mind. Yes, we do have standard, but the standards are arbitrary. There's a reason why the pinout of RJ45, in other words, have this specific sequence of wiring pinouts, because we as humans came up with it. So we decided a standard for these cables, and most commonly used ones that you probably heard on the on the industry as well as at home is the T568A and T568B. Now, where do these T568 numbers come from, right? That's another question you ask. So the next few slides, I'm going to introduce you to the background behind these arbitrary standards that humans, we came up with for standardizing our network environment. So keep that in mind. So unlike natural sciences, computer science is a lot to do with arbitrary standards that we human came up with to make everything work, as opposed to studying like a brain function or something like that. That is not an arbitrary thing that you actually had to study what is already there, right? So keep that in mind. So the reason why we have these type of RJ45 pinouts, for example, is because we came up with those arbitrary standards. So the standards that are really important to IT professionals, especially students and who are starting out in the information technology, is the ANSI TIA EIA 568D, ANSI TIA 569E, and ANSI TIA EIA 570D, and ANSI TIA EIA 606C, 607C, and 758. Those are the couple of standards that I'm going to introduce to you. And those are the key standards that you should be familiar with as an IT professional. So the 568D includes the commercial building telecommunications cabling standards. .0-D is a generic communication cabling for customer premise, and the .1-D is the commercial building standard. .2-D is the balance twisted pair telecommunication cabling and component standard, and .3-D is the optical fiber cabling components. Those are still in use today, and those are the standards that you should be familiar with. The 569E is the commercial building standards for telecommunication pathways and spaces, and the 570D is the residential telecommunication infrastructure standard that we use. And when it comes to point 606C, that is the administration standard for telecommunication infrastructure for commercial buildings. So if you become an IT technician for a commercial building, that's the standard you should be following. The 607-C is the commercial building grounding and bonding requirements for telecommunications that sometimes overlap the electrical standard and electrical codes as well in the whatever the local area that you're working in, Canada, United States, for etc. The 758 standard is a customer-owned outside plant telecommunication standard, also known as OSP standard. So these are few standards that you should be familiar with. You should know what these are. If your instructor or professor asks you what is 569E, you should be able to tell me this. And if I ask you anything about this, you should be able to tell me what's under 568-D, and you should be familiar with all of these few standards, because there are way more standards than this, but these are the key important standards that every IT professional, in my opinion, should be aware of. So let's look at the T568A and T568B termination standards. I briefly introduce you to this concept a few slides ago. So this is the widest known and most discussed feature of ANSI TIA 568 documentation, because ANSI TIA 568 is a huge documentation that has a lot of different standards and cover many things, including the pinouts as well as the cables themselves as well. One of the common thing that you hear not only in the industry but also when you as a consumer is the T568A and T568B. So these actually define the standardized pinout or pin to pair in network cabling with RJ45 cable jacks. So these are RJ45 jacks in here, and the T568A and T568B termination standards will define how pin to pair or pinout, the term that I have been using on my previous slide. Pinout basically means how those pins are coming out of this jack. That's the order or sequence of these wires are put together in this cable on this particular jack is called pinout, because it's pinning out is defined by the TIA ANSI 568 standard. So there are two alternative pinouts that are introduced by both standard organizations as well as the initial research done by the American military organizations. One called the T568A and T568B. Now you may ask which one should you be using. It doesn't matter. For straight through cable, both ends should be T568A or T568B, either one of them. If you use one side T568A, you should use a T568A on the other side as well. For crossover cable, one side you can use the T568A and the other side you can use the T568B, making the cable crossover. I will go into depth of what are the differences in different types of cable pinout, but what you need to remember for now, as the T568A and T568B termination standards defined how pinout is done on RJ45 jacks for Cat5, Cat5e, Cat6, Cat7, etc. cables. So here is a documentation that has been put together by Wikipedia. I just basically took a screenshot from Wikipedia because there's no need to recreate this. So you have pins 1 to 8, and pins are counted the way that is shown on this diagram right here. And there are different colors of wire associated with these different pins. Different wires, I mean. So T568A have a certain sequence, and T568B have a certain sequence, and you follow those sequence accordingly how you gonna wire your cables. This table also defined what those wires are doing with respect to the data transmission, such as TX1 plus TX TX plus TX minus RX plus and all the other, the other information in here. But for now, forget about this part of this table, but remember there are two ways of terminating your CAT cables. So as we move through this course, progress this through course, I will go into deeper and deeper into structured cabling standards, and I might go into some depth of how these pins are important and why we have this information set up in the way they are. But keep in mind, these standards are arbitrary. Human created these standards, and these are the standards we use globally, so that all the switch manufacturers, router manufacturers, other equipment manufacturers, and structured cabling manufacturers can be on the same page, so there are no conflict, right? So keep that in mind. I'm going to briefly introduce you the difference between the straight through cable versus the crossover cables. So straight through cables are used for dissimilar devices, and crossover cables are used for similar devices. Modern day, most equipment will accept straight through cables because the internal components of those devices are smart enough that it will automatically switch to whatever it needed to be switched into to make the system work. So you can either use straight through cable or crossover cable with any intermediary or end devices in modern time in 2022, and the system will automatically speak to each other and make it work. However, on my previous courses, I have introduced you to the differences in straight through cables and crossover cables, especially in my network engineering classes that I have done with associated with the CCNA courses that I have already posted on my YouTube channel. If you haven't seen my CCNA lecture series, which are more than 50 plus hours of lecture series, you can go ahead and check out my YouTube channel, and there are a lot of information in there, and that explains the differences in straight through cables and crossover cables as well. What you need to remember in generally for your exams and laboratory environment is that straight through cables are basically used to connect unlike devices, while crossover cables are used to connect like devices. So on an exam, for your, depending on who you are taking the course with, which academic institution, this question is a very common question that pop-ups oftentimes. So many organizations in Canada as well as in the United States and during exams may ask this question: what is a straight through cable, and how it is used compared to a crossover cable? So straight through cables, because they are straight through, are used between unlike devices. So switches and routers, for example, switches and computers, for example, or a router and some other different device. Crossover cables are used in like devices. So you can use between switches, between routers, between router and the end device. That's how we're gonna use the crossover cable, because they are basically like devices. So unlike devices tend to typically use straight through cables, while like devices have to use crossover cables so that the communication would happen properly. Again, I just want to emphasize this: in modern day 2022, most Cisco switches, most D-Link routers, most IBM routers and switches, and most HP distribution points, etc., will take either straight through or crossover cable, and it'll just work fine. In fact, most of the so-called patch cables are actually straight through cables. They are not crossover cables, and the system just figure out what to do. But this is a fundamental concept that came from the history of structured cabling, and you should know this. And also in my previous courses with network engineering, I have told you that there is a way that you can actually disable auto negotiation of crossover straight through cables on Cisco switches and routers. So for some reason, if your system administrator, network administrator disable that auto negotiation and you use the wrong cable, the system will not work. The network will not communicate. So that's why this is still important. Even when we have auto negotiation between different devices and network interfaces, we still try to maintain straight through cable and crossover cable differentiation. And how would you make a crossover cable? You can use one side T56A and the other side T56B standards, and that would make a crossover cable. Again, I will go into depth of crossover cable, patch panel cable, and different types of cable in my future lectures. But keep in mind, there is a difference between a straight through cable and a crossover cable if you have heard these two terms before. Cable standards. So I'm going to briefly introduce you to some cable standards because these are common terms that you probably heard already in the industry or at home. They are defined by ANSI, TIA, and IEEE. So 3 organizations work together in most cases to define those standards. And the common current standards include the Cat 1, Cat 5, Cat 5e, and Cat 6. So each time we move on to a new category, there are certain improvements in technology and how the transmission quality and what kind of data and how much bandwidth and throughput going to be there. I will define what are those, what we mean to be a throughput, what is bandwidth, etc. in my future lectures. But keep in mind, every single time we move up the category, we try to improve the quality of our cable standards. And basically there's a cat fight. So that's why we have a cat in here in a closet. We having a cat fight between different cats. These are called Cat 1, Cat 5, Cat 5e, Cat 6. They're not really fighting. I'm just saying, like, it's trying to improve, like beat down the other previous category and be the better category in the next iteration. So each time, for example, the difference between Cat 5e and Cat 6 is the cable length, most to do with cable length. Even though Cat 6 do support better, transmission quality, in most use case scenarios, Cat 5e is the maximum of 100 meters, for example, and the Cat 6, then it starts to degenerate the signal, and the Cat 6 can do more than 500 meters, for example. And there are also shielded pair, twisted pair versus unshielded twisted pair, and whole bunch of other items associated with that. And all of that I will describe and go into depth in my next future lectures. So make sure to subscribe and stay tuned for the cat fight lecture in the future, in this particular lecture series. Until next time, good luck with your exams and have a nice day.